Hello and welcome back to Algebra 2 with Miss Faust. It's been a while since we've seen each other in this form, but we're back and ready to do some more notes. So here, this is Unit 3. In your book, this is Lesson 6.1 and 6.2. Our essential question is, how do I add, subtract, and multiply polynomials? If you remember complex numbers, this all works very similarly. The difference is with polynomials, we get bigger exponents that we have to work with. So the big idea here is that we are trying to go from intercept form polynomials, which we graphed last time. So intercept form is something like y equals x minus 3 times x plus 2 times x minus 4. And remember, this one's easy to graph because we can find the degree, 1, 2, 3. We can find the intercepts, 3, negative 2, 4, and sketch the graph. But often we want to express things in standard form. So standard form would be something like y equals x cubed minus 5x squared minus 2x plus 24. So what we're going to learn today is how we can get from intercept form into standard form. And in order to do that, we have to be able to add, subtract, and multiply polynomials. So that's why we do this, is so that we can convert equations from intercept form to standard form. And if you're wondering, will we go back the other way? The answer is yes. It will be what we do next. We'll look at dividing and how we go from standard form back to intercept form. But for today, let's stick with this. So to add polynomials, and this should be kind of familiar from Algebra 1. When we add, we combine like terms. So what we just have to do is remember to find like terms and then put them together. So for example, let me just do a little focusing here. For example, if we had 3x squared minus 4x plus 5 plus negative 2x squared plus 2x minus 6. So for adding, we basically can just drop the parentheses, 3x squared minus 4x plus 5 plus negative 2x squared plus 2x minus 6. And then we look for like terms. And like terms are things with the same variable or letter and exponent. So in order to be like terms, you have to have the same exponents. That's important because when we get into multiplication, we don't need like terms in order to put things together. So when we're looking at adding like terms, then here we would look for everything with the x squareds. So I've got those two. So 3x squared minus 2x squared, when I put those together, 3 minus 2 is 1x squared. So I'd get that from those two like terms. Negative 4x and positive 2x. And I know the orange pen doesn't show up really well, but I'm just using it as an example here, so calm down. Negative 4 plus 2. Negative 4 plus 2 leaves us with minus 2x. And then the last two like terms there are the positive 5 and the negative 6. So we put those two together, and positive 5 and negative 6 together give us a minus 1. So our answer when we're adding polynomials for this one would be x squared minus 2x minus 1. I'm not going to do more examples of that because most people have a pretty good sense of how to add and subtract. So rather than waste your time, we'll go right on to subtraction. If you need to see more examples of this, maybe just make a little note in the margin, and then next time I see you in class, you can be like, hey, Miss Faust, do another example for me. And I'd be like, yes, I love math. I'd be happy to. Okay, so when we subtract, the first thing you have to do is distribute the negative sign. To everything inside the parentheses. And then combine like terms, just like when we add. Okay, so for example, if we have 3x squared minus 4x plus 5 minus negative 2x squared plus 2x minus 6. Notice this is the same problem as before, only with some subtraction in between instead of addition. Just slide that down a bit. So what we want to do first is we want to take this subtraction sign and distribute it to everything inside. So we change this to a plus, and we change everything inside to the opposite. So I make that a plus 2, I make that a minus, and I make that a plus 6. I realize that's a little bit hard to see. I'm not sure why I'm having so much trouble with the light today. Maybe better, but it might change to worse. We'll see. So at this point, we do the same thing as when we add. So we just rewrite it without the parentheses. So now we have plus 2x squared, now we have minus 2x, and now we have plus 6. So we go through again and we find like terms. 3x squared and 2x are like terms. So 3x squared plus 2x squared is 5x squared. Sorry, 3x squared and 2x squared are like terms. Negative 4x and negative 2x give us negative 6x, and 5 plus 6 give us 11. So we get 5x squared plus 5x squared minus 6x plus 11. Okay, so again, we're just taking that subtraction, distributing it to everything inside, and then rewriting the problem and adding. Again, I'm not going to do lots of examples of that because I think people are pretty good with addition and subtraction. So let's take a little bit of time now on multiplication. Again, multiplication is not too difficult. Most people remember some of this from Algebra 1, so you should be in pretty good shape. When we multiply, what we want to always do is we want to multiply all parts of all parentheses. Okay, and when you multiply, the things to remember is that you always multiply coefficients and you add exponents. So big idea, multiply all parts of all parentheses, and then that means that the coefficients get multiplied together, the numbers in front, and the exponents get added. I think you'll remember that as you start to see them. So for example 1, I'm going to start simple and get more complicated. Negative 3x to the second, y to the fourth, times negative 2x to the third, y to the third. So really this, when you don't have any addition or subtraction in between them, you're really just multiplying all of these pieces together. So when we multiply all the pieces together, we multiply the negative 3 and the negative 2. Negative 3 times negative 2 is positive 6. We multiply x squared by x to the third. And when we multiply, this means we have 2 x's, this means we have 3 x's. So if we have 2 copies of x and 3 more, we end up with x to the fifth. And finally, the y to the fourth and the y to the third. So 4 y's plus 3 more y's gives us y to the seventh. So that's where the multiplying coefficients and then adding the exponents on the x's and y's come together. Okay? So another example, this one will have a couple more terms. So if we start with negative 3x squared times negative 2x to the third plus 2x minus 6. When we have something like this, this is just the old-fashioned distributive property. So remember, the distributive property means you multiply whatever's on the outside by everything on the inside. And again, coefficients get multiplied, exponents get added. So one thing to remember is if you just have an x, there's always a hidden 1 up there. Remember, mathematicians are super efficient, so they like to put those together. So my first term here, I would do negative 3x squared times negative 2x to the third. That's those two multiplied together. Then I would do negative 3x squared times 2x to the first. That's that one times that one. And then I would do negative 3x squared times negative 6. Negative 2, or negative 3 times negative 2 is 6. X squared and x to the third is x to the fifth. Negative 3 times 2 is negative 6. X to the second and x to the first is x to the third. 2 plus 1 is 3. And negative 3 times negative 6 is positive 18. And x squared and no x's is just x squared. So my final answer here, 6x to the fifth minus 6x to the third plus 18x squared. Then we get into cases where we have even more interesting polynomials. And for a problem like this, we'd have something like x plus 2 times, let's do 2x plus 5, and then we'll do one more example after this. So again, remember with this, we need the box method or FOIL. I'm going to show the box method just because it's what I think most people use now. So we put x plus 2 down here and 2x and plus 5 over here. So we go through and multiply it. X times 2x is 2x squared. X times 5 is 5x. 2x times 2 is 4x. 2 times 5 is 10. So we get 2x squared plus 5x plus 4x plus 10, or 2x squared plus 9x plus 10. So we're really combining like terms in the middle of this also because we're putting together those like terms. Some people just do it right here and write it there. That's fine too. Okay, so one last example. And this is what happens when we have more than two terms, because most people haven't seen that yet. Don't worry, it's just like when you have two terms, only you have more. So x plus 2 times 3x cubed plus 5x minus 4. So now, if you're used to using the box method, this will be really easy. The only difference is going to be that across the top you're going to put 3 pieces instead of 2. If you're used to using FOIL, you can still do it for this. It just gets a little more complicated because you have to remember to multiply the x by all 3 of these pieces and the 2 by all 3 of these pieces. Again, I'll show it with the box method just because that's what most people are doing these days. So I have x and plus 2. And then across the top, I'm going to put 3x to the third, 5x, and negative 4. And now I multiply. 3x to the third times x. Well, remember, again, this x has a little hidden 1 on it, and that one has a hidden 1 on it. Might be helpful just so that you don't forget about those when you're multiplying. So this gives us 3x to the fourth. This gives us 5x to the second. This gives us negative 4x. I'm just multiplying x by each of those. Now I'm going to multiply 2 by each of those, 6x to the third, 10x, and negative 8. So I'm going to write all that out and see what I can combine. And I notice I can't combine. Oh, I can combine 2 of them, and only 2. This one and that one. So when I write my final answer, I'm always going to write it with the highest exponent first and the lowest exponent last. So I'm going to write 3x to the fourth, then 6x to the third, then 5x squared, then negative 4 and 10 together will give me positive 6x, and finally minus 8. So that's my final answer, exponents highest to lowest. And you'll notice it's just like what you've been doing before. You just get more boxes and more numbers when you're done. So standard form polynomials do get complicated. That is okay. A couple quick notes before I sign off for today. When you add or subtract polynomials, the exponents don't change. And I'm writing this out because these are common mistakes people make. When you multiply polynomials, you multiply the coefficients or the numbers in front, and again you add the exponents. So in these, the exponents do change. So exponents are only going to change when we're multiplying polynomials, never when we're adding or subtracting. Hopefully that's a helpful little tip. And thank you for your attention today. Have a wonderful day. I'll see you next time.